All right, with messages represented as vectors, we can finally train our spam ham classifier. Now we can actually use almost any sort of classification algorithm. So one of the ones that may be the most optimal will be to use the naive Bayes classifier algorithm, and that uses mathematical statistics to be able to classify some of the data. So when I go into detail, we can check that link. So we're gonna from the sklearn.naive Bayes import. We're gonna import the model, which is called the multinomial NB. We're gonna call our object spam detect model, and we're gonna create an object by using the multinomial NB, and we're gonna fit our data messages. That's going to be our input, and the correct values is going to be the goal is to be able to predict these labels. And so we want to be able to print. Let's see how well this predicted. So that's our model, and we're gonna call this predicted spam detect model dot predict, and we're gonna TF-IDF4. That's the name of our vectorizer, and we're gonna look at specifically at one of them at index 0, and let's print the expected value. Messages dot label 3. So you can see that we actually did pretty good, right? It was predicted that it was going to be ham, and expected was ham. So that's good. That was a good prediction. Now what we're gonna do here is let's actually do this for the entire system. So we're gonna make a prediction for all our data. Predict for our messages dot tfidf print are all predictions. So we can see the predictions that we're actually making. Now we can use a so this diagram here. We kind of see what the confusion matrix will show us, right? We can see the false negatives, the true positives, the true negatives, and the false positives. So we can see here what the values would be if we have a confusion matrix. So we can use sklearn to build a classification report, which returns the precision recall F1 scores, which is all done using the confusion matrix and the column to support, meaning how many cases supported the classification. Check out the links for more details if you want to see more about that. Here, the precision, remember the precision formula is how many of the relevant elements are true positive divided by the how many elements do you have, right? So this is where we get the true positive. Let me clear this. So this represents our true positives and this is how many we got. So remember this right here, this represent the actual correct answers. So all these ones were the correct, where we guessed correctly, and these ones are where we don't guess correctly. That is a that it was the correct solution. That was the correct answer. Okay, so that's how we get those values. So how many retrieved items are relevant? Well, we do it by dividing the actual correct ones by the total ones that are correct. That is supposed to be positives, and then the that by total of numbers who are, the precision is done by the true positives divided by the all the positive ones, all the ones that were determined to be positive, and the recall would be dividing the true positives divided by the numbers that are supposed to be positive. And so the way we can calculate that we would be with the formulas from sklearn dot matrix import classification report, right? Remember we use this one for the confusion matrix, and we're gonna print the classification report with the messages label. We're gonna use that as reference, and we're gonna compare it to all the predictions. And let's see if that works. Yep. This is quite there are quite a few possible metrics for evaluating model performance, which one of the most important depends on the task and the benefits effects of decision based of the model. For example, the cost of mispredicting a spam as a ham is probably much lower than missing a ham as a spam, right? What does that mean? It means that we rather the computer or the machine to predict a spam to be not a spam, right? We'd rather have it in our emails, right, where we can see them, or not being blocked, right, than having an actual message to be categorized as a spam, because that will be more. What about if we're missing important information? So that's very important that we distinguish which ones are more relevant, what weight value, what precision, how we want to be able to determine which one will be a better way to determine how efficient our machine learning prediction is. In the evaluation, we evaluate accuracy in the same data we use for training. We should never actually evaluate on the same data set. So we made a mistake of actually training our data and testing our data on the same data, and we usually never want to do that. We always want to do a split, right? And so remember, to be able to split our data from the sklearn dot model selection, we're gonna import the train underscore test split, and we're going to separate our train, our message testing test, let's call it test, our label train, our label test, and this is going to be equal to train underscore test split. We're going to split our data with the message. So that will be part of our message train, and then messages will be for our label. This is going to be our label distribution. And the way we want to do this is we want to separate this by test size by 20%. So 20% will be for our test. And let's print our length for our message. So let me just do this. Label. Oops, forgot an L here on label. All right, so we can see here that we're going to use 4,457 for messages for train, 4,457 for our label train, and then messages test will be 1,115, and then for the message test and for a label test will be 1,115. We want them to be the same as this guys, right? So that's 20% of the messages. Usually we do, the default usually is 3070, so it depends on how much data you actually have. For now, what we'll do is we're going to create a pipeline that is going to make our life a little easier, so we don't have to do this all one at a time. We can run multiple data in this pipeline. And we're going to import the pipeline, and we're going to use pipeline. Why did this do this? I don't need this one. Pipeline, and we're going to create a pipeline. We're going to use the constructor, and inside here we're going to put inside the pipeline our what do we want to be able to categorize. So let's do bow, oops, sorry, count, vectorize. So what we're going to do is we're going to do everything that we just did, but now all in one single line. We're going to we're going to use the analyzer, which we said was going to be our text processor, right? This is going to take away any of the punctuation and remove any of the stop words. And then we're gonna do our we're gonna do the TF-IDF, right? The frequency wave value, and that's going to be done by the TFI transformer. And then the classifier, we're going to use for the classifier, we're going to use the multi-monomial NB. Okay, so let me just add some information here. So this is practically what it's doing is we're strings to tokens. So we're turning strings to tokens, integer counts. This is practically doing integer counts to weight TF-IDF force. And we're going to train on the TF-IDF vectors with the naive base classifier. Why is this saying that it's not defined if we actually define it? Just gonna copy here. Sometimes you misspell something and we want to make sure that it's spelled correctly. There you go. I just misspelled it. So now what we're gonna do is we're gonna use the pipeline. The pipeline to fit our data. Message train label underscore train. So it's gonna take a while probably because we're training the data. And we're almost done, so I'm gonna make this. We're gonna do the predictions. Predictions equals pipeline dot predict of the message underscore test. So we want to check if the predictions are correct. So this is going to be our predictions, and then we're going to print our classification report with the predictions label underscore test. So let's check how well these predictions are done and how well our report does. Yeah, so we can see here our precision recall and F1 scores about our ham and spams. Now we have classification report for our model on a true test instead. There's a lot of more natural language processing that we have not covered, and it has a vast, expansive topic that you can fill up the several college courses. I would encourage you guys that you check out other resources below for more information about NLP. But that's all we have done. I mean, I just wanted to give you guys a taste of the NLP. This is done. This is very useful for kind of like companies like Google and Amazon that is sometimes searching for people who most recommended searches and stuff like that. So they use this natural language processing for that, or Alexa, right? So that they do it as well. So I don't want to keep it longer, so I'm gonna stop here and see you guys next time.